Alright, next in our states of matter are our solids. And your solid particles are not free to move about each other like gases and liquids. Instead, they're going to vibrate about a fixed point. So they're kind of sitting in one spot, just kind of shaking. They are packed tightly against one another in a highly organized pattern. So here's our solid. Solid, when you put it in a container, it's going to have a fixed volume, so it's going to hold its shape. The liquid also has a fixed volume. Remember, it's not compressible, but this is going to take the shape of its container. And then your gas is going to take up the volume of its container. So if you were to shrink the container, then your gas would become more dense. So because it can take the volume of its container, it's also going to take the shape of its container. As far as solids melting, as you increase the kinetic energy of those particles, they're going to start to vibrate more rapidly. So picture a house of cards built on a table, and you're starting to shake that table. Well, the more you shake the table, those cards are going to start to shake, and then that organization is going to break down. So same thing's going to happen with the solid. You start to apply heat, those particles are going to start to vibrate more rapidly, and then that's when your solid is going to melt. Melting typically occurs at a specific point, a specific temperature, where the solid becomes a liquid. Melting can be reversed by either cooling or freezing the substance. Not all of your solids are going to melt. Things like wood, sugar, and organic compounds decompose. Since you are an organic compound, you do not melt, you will decompose. So a solid to a liquid is melting, liquid to a solid is freezing. Melting points is going to be the substance where a substance goes from a solid to a liquid, and because the point where it becomes goes from a solid to a liquid is also going to be the point where it goes from a liquid to a solid, the melting point and freezing point are going to be the exact same temperature. For ionic compounds, you're going to have really high melting points. So table salt melts, not dissolves, melts at 801 degrees Celsius. Molecular compounds, however, so your covalent compounds, they're going to have extremely low melting points. So things like butter, hydrochloric acid has a melting point of negative 112 degrees Celsius. So you would have to cool hydrochloric acid to negative 112 degrees Celsius to get it to freeze, become a solid. So solids have specific shapes, and most solids are going to form some type of crystal. So crystals are solids where your atoms, ions, or molecules are arranged in an orderly, geometric, three-dimensional structure. And for an ionic solid, the locations of those ions can be represented on a framework called a crystal lattice. So a crystal lattice is formed from unit cells, and they are the smallest arrangement of connected points repeating in 3 dimensions. So think of a outlined box that's going to be stacked on the sides and the top and the bottom. So this repeating pattern is what's going to give you your crystalline form. So depending on the shape of the solid is going to be determined by the unit cell. And we're going to look at just 3 unit cells. We're going to stick to your cubic unit cells. So the first one here is a simple cubic. So on each corner you're going to have a portion of an ion or an atom. So where this corner would join 1, 2, 3, 4, 5, 6 other boxes is where you would get a whole entire atom. Next is the face-centered. So in addition to the corners, you also have half of an atom here, a half of one here, a half of one here, and a half one here. It's not technically a half, but it's being shared by both. So you would count it as a half. And then last is body-centered. So you would have a whole one inside of the cube here. So this unit cell can actually be used to determine the formula of an inorganic compound. Which brings us to amorphous solids. Not all solids have a crystalline structure. Amorphous solids are going to lack this internal organized structure. Things like rubber, plastic, asphalt, glass are amorphous solids. They're going to cool to a rigid state without crystallizing, so they're going to be kind of scattered. They tend to not have a definite melting point. Instead, they're going to soften gradually. So if you think about melting a plastic bag, it doesn't go immediately from a solid to a liquid. It kind of hangs there in suspension almost. Glass is the same way. It softens gradually, which allows artists to blow glass and make vases and such.